In this question, we have a sample. We have taken a sample from a population, and this population mean has the population has a certain mean, and we have a certain sample mean. And we also find that we have a standard deviation of our sample, which is 9.0, and the sample size is n equals 9. And we are asked to find out what is the sample standard deviation of the sampling distribution. Now, what does that actually mean? Now, let's just simply say, for simplicity's sake, our original population might look something like that. It doesn't really matter. Here we would have our population mean, and we know that this is a population because it's abbreviated with this mu sign, so that's the mean, and it probably has also some standard deviation here. And this standard deviation would be abbreviated with a sigma sign. So that's our standard deviation for the population. And these are our parameters. Parameters, mu and sigma for our original population. And now I can draw samples from that. I just simply take a sample of this population, and this sample would be characterized by the sample size. It would be characterized by the mean of the sample, that's the x bar, and it would be characterized by the standard deviation. Now, if I take loads and loads and loads of these samples with sample size n, then the central limit theorem tells us that we would end up with a normal distribution. So that would be our sampling distribution. So sampling distribution for all of our samples, sampling distributions, and this sampling distribution has, again, it is a population, because we can do that 1,000,000 times. So we would have the mean, population mean of the sampling distribution, and we usually abbreviate that as mu x bar. So this is the mean of the sampling distribution And it is a normal distribution. Again, it has here the standard deviation, and in this case we have a population standard deviation, and it is the standard deviation of the sampling distribution. So that is standard deviation, of the sampling distribution. And that is actually what we are looking for. And we know that in this case, our mean of the sampling distribution, so mu x bar, equals our sample mean, and that also equals the population mean of our original population here, from which we have drawn the sample. We also know that the sample standard deviation of the sampling distribution, and that's quite a mouthful, this sigma x bar equals the standard deviation of our sample, that is this S here, the standard deviation of the sample, divided by the square root of the sample size. And that is actually what we are asked to calculate. So we can do this calculation quite easily because we know that we have a sample standard deviation of 9. So in this case we have 9 divided by square root of 19, and this would give us the sampling distribution, the standard deviation of the sampling distribution, 9 divided by square root, and I abbreviate that in Excel with SQRT. Mustn't forget the brackets. So this gives us the square root of the sample size, and here we have our standard deviation. So this is the standard deviation of our sampling distribution. And very often we are trying to when we use hypothesis testing, we cannot use usually our original population because we usually don't have this standard deviation of our original population. We don't know that, but we know actually the standard deviation of our sampling distribution, and that's why this equation here, why this calculation is quite important to carry out.